muted. There we go. It's not muted anymore. I almost got it right. One day I will get that. Right. How are we all doing? How is everyone? I'm still muted. Lies. How about that? Surely not. We're not muted now, right? You can all hear me, yeah? Good. Right, you can hear me. Excellent. Right. How are we all doing? You all managed to survive Easter. Why? I kind of look grey. So you all managed to survive Easter all right, and no doubt you're all desperate for some more work. I have almost no work. Well, let me fix that for you. It's not. I will level with you. It's not going to be the most in-depth lesson from my side of things today. We're going to go through a few bits and bobs. There might be a couple of notes for you, but rather than sort of launch into the technical side of logic, which is the unit that we're going to look at, I figured it would be better to start you off with some of the logical thinking that goes behind it, so that you can see, well, what's the point in all of this stuff. So a lot of this stuff is going to be a recap of stuff that you have done in Year 9. However, there might be a number of you who thought, you know what, I didn't really do anything in Year 9, so I can't remember any of this stuff. There might be others that did do stuff in Year 9, but they can't remember any of it. We'll see how it goes. Basically, you've probably already all seen the worksheet that I've stuck up on the Google Classroom. Hopefully this video should help you out as to why I want you to do that stuff. I'm sort of rambling here, so shall we just get on with that? You might need your notes open. There might be a few notes for you to take. First of all, there is a guy here. Let me turn on my pointer. This guy. Does anyone know who this guy is? If you think you know who he is, just say his name in the chat. Who is he? Does anyone know? Anyone got any ideas? Do you want to have a guess? Guy. It is not Guy. That is not his name. It's not Earl Grey, although that's I would say that's a good guess, but it's not really. It is not Earl Grey. Mr. Boolean. You're very close with Mr. Boolean. It's not Mr. Boolean. That is Mr. Boole. George Boole is his name, after whom most of the true or false logic values in programming languages are named after him, and also the whole field of Boolean logic is named after George Boole. He was a self-taught mathematician. Self-taught. So there you go. And he didn't even have the internet to help him. So we're going to have a look at his legacy. We're going to have a look at these things and not. You might recognize these things from maths, and you might think, oh, that's just intersection and union and exclusion. Well, kind of. So we're going to have a look at that stuff. All right. So by the end of this lesson, you will be able to do all of these things. You'll be able to name the two possible values associated with Boolean logic. I've already said what those two values are. While I'm reading out these objectives, you can type in what those two possible values associated with Boolean logic are. Type them into the chat. You will also be able to explain how logic can be used to help make decisions, and you will be able to solve some logic problems using basic logical principles. True, false. True, false. Red, blue. Not, nor, through. True, false. Trolls. Green. True, false, glowfly true, glowfly false, good, bad. Well, true or false are generally the values, although Booleans can be used to represent any two opposing views. Yes, to be or not to be. Here's the first task. The first task for you. Describe this thing in as much detail as possible. Now bear in mind what we're talking about here and what I'm driving at. What is that thing? Maybe you could chat to each other on the Discord and then give me an explanation. Yeah, it's a switch. But what else about it? What other information can you give us, Clicky Boy? Can you give us any other information other than the fact that it is a Switch? Not to be confused with the Nintendo Switch. It turns stuff on and off. Yes, it does. Okay? It turns stuff on and it turns stuff off. A switch in a square with two holes on the side of it. That is a physical description. You can flick the switch to turn the light on or off. If the mains is off, it won't work. It has a Boolean state unless you're skilled. No, even if you are skilled, EV is in with the with what I'm driving at here. It's either on or off. It's not halfway in the middle. Now, Alex has suggested that if you are if you get your fingers in the right position and you get that switch sort of like leveled off, then you can make it go half on and half off, but it ain't going to dim the lights or anything like that. It's going to still flicker between those two states. Okay, it can either be on or it can be off. Electricity is flowing or electricity is not flowing, right? And that, my friends, is also what we see in a transistor, inside the CPU. Okay, not going to go through this. We've just been through that without my prompting. Here are some notes for you, though. Okay. There are only two states in Boolean logic. Things are either on or they are off. They are true or they are false. What if it was a switch for a light where once it is on, the brightness or colour can be changed? It would still... there's still only two states. It's either on or it's off. And then you'd have another controller, which would control the brightness or the colour. That switch itself is only doing one thing. It's turning it on or it's turning it off. Okay. And first of all, right, we're gonna sort of do away with any of the thoughts that you might have about things in between states. Right. We're talking about Boolean logic here. Things are either true or they are not true. Yeah. So there might be situations in life where things can be one of many different states, right? But that is not what we're talking about here. We're talking about two different states, on or off. Okay, so each element in Boolean logic can exist in only one of two possible states at a time. It is either on or it is off, true or false, 1 or 0. Okay? If you look at the state of an element, you can work out the state of other elements. Okay? We're not talking about superpositions of light switches or anything like that. Okay? Does that make sense, what I've said here? On a fundamental, basic level, the two states of Boolean logic are either true or they are false, they are on or they are off. Does that make sense to everyone? Just say yay or nay. And they never said anything ever again. There we go. Okay, cool. So first of all, when we're talking about an entirely, if the world see how I can phrase this, right? The world is a messy place. The world in which we live does not conform strictly to Boolean logic. Okay? Usually there are more than two states something can be in. Okay? It's not a case of either you're awake or you're asleep. There's that time in between where you're sort of half awake, but when we're talking about Boolean logic here, we boil it down. We remove any of those. Oh well, what if it could be this or it could be that? No, if something is on, it is not off, and if something is not off, then it must be on. That's sort of like where we're going. There are no shades of grey here. Okay, this topic is logic. Okay, that's what the topic is. It's all logic. Okay, so as long as we're clear that there's no sort of trick questions here. Any of the questions, the puzzles, the riddles that I give you are going to rely on the fact that if you know the state that something is in, you also know the state that it is not in, and there's nothing in between, right? I'm going to give you an example now. Okay, here is the example. This thing here is a widget. It doesn't matter what it does, okay, but a widget can either be blue or red. Those are the two colours that widgets come in. They are blue or they are red. There is nothing in between. Okay? Alice asks Bob what colour his widget is. That's right. Bob tells her it is not blue. So what colour is Bob's widget? I see some of you have already jumped the gun. Alex with an incorrect answer. Alec with an even more incorrect answer. Ollie with the correct answer, and Nicola with the correct answer there. James with the correct answer in French. Is Akai a colour? But yes, how do we know that Bob's widget is red, even though he hasn't explicitly said that it is red? What's the logical thought process that goes behind that? Yeah, it can only be red or blue, and it isn't blue. Okay, therefore there's only one possibility. Right? Now, obviously, in the real world, if Alice said to Bob, what colour's your widget? And he said, well, it's not blue, Alice would probably walk away and think, this guy's an idiot. He won't give me a straight answer. Because it could be one of an infinite number of different colours. But in our logical kingdom, where it's either one or the other, it's blue or red, black or white. Okay. Yeah, and just to answer this question here, what if he painted it? That's not an option. Okay, we're talking about an entirely Boolean logical world where there are only those two possibilities. There's nothing else that can happen. If it's not blue, it must be red. If it's not red, it must be blue. Okay, those are the only things that could happen. Okay, so let's have a look at a slightly more complicated example here. A football team can either be the best in the world or the worst in the world. There is no in between. There's only two things that a football team can be. They're either the best team in the world or they are the worst team in the world. Okay? There is nothing in between. If Jeff's favourite football team is the best in the world, he will party all night. Okay? If Jeff parties all night, he will be late for school. Jeff's favourite football team is Chelsea. Okay? These are four predicates. These are four rules that we know. These are four things that we know, and we can derive an inference from them. We can use this information to arrive at a logical conclusion based on here. So let's say Jeff arrives at school on time. What does that tell us? Okay? Chelsea is the worst team in the world. Okay, so yeah, let's sort of like backtrack here and find out like the steps that we go through here, right? Jeff arrives at school on time. Okay, now look at rule number 3 here. If Jeff parties all night, he will be late for school. So because he's arrived at school on time, it means he has not arrived late. So if he did not arrive late, that means he did not party all night. Okay? Now, based on that, if Jeff's favourite football team is the best, he will party all night. Well, he did not party all night because he arrived at school on time. Therefore, his favourite football team is not the best in the world. But rule number 1 says a football team can either be the best in the world or the worst in the world. Jeff's favourite football team is not the best in the world, therefore it must be the worst in the world. And Jeff's favourite football team is Chelsea, therefore Chelsea is the worst team in the world. Okay? Does that make sense? Okay, it's a little bit more complicated than Alice and Bob's widgets, right? But Ben says, well, no. What's the well, no? What's the... Wherein lies the confusion? Ben likes Chelsea. I mean, there's no account. I mean, I don't know anything about football other than that it's unbelievably boring. I mostly put this in here to get a rise out of people, because that's me being a troll. Okay, but we can't. So we get what's going on, yeah. I agree, football is boring to watch. Unless it's American football, and then it can be fun sometimes. Right, here we go. So, I got a question for you all now. Have a quick discussion, yeah? And I want you to think... I've said that the real world doesn't apply in strictly Boolean logical terms, but we can still use this sort of logic to help us make decisions in real life. Okay, so what I'd like you to do, just discuss for about 5 minutes how this sort of logic can help us make decisions about the world that we live in or our day-to-day lives, and see if you can come up with either an example or an explanation. While you do that, I am going to go and make myself a cup of coffee. Okay, I'll give you some music to vibe to while I go and do that. And then when I get back, you guys can explain to me some of the ways that logic can help you make decisions. Okay? Right, okay, so hope you enjoyed listening to the final battle of the Dark Wizards. That is by Kevin MacLeod at incompetech.com, as well you know. I'm not muted. Not muted. Okay. Am I still muted? No, I'm not muted. That's what I thought. Right. I am either muted or I'm not muted. Just like you guys are either gonna pass or fail. Right. So, how can logic help us to make decisions in real life? Go. You're either Josh or you fail. If a car was heading right towards us and on the right of us there is a 90-degree cliff, on the left is an escape path, you wanted to live, where would you go? Yeah, okay, so there's a whole bunch of stuff going on there. And although the real world is kind of messy, you can still put that into Boolean context. The car is heading towards you at 90 miles an hour, right? If you stay where you are going to die. Okay, now with Boolean logic, you have true or false values. I'm assuming that you're saying, right, you've got a path on the left, a path on the right. Staying in the middle is not an option. But you're either going to head to the left or you're going to head to the right. If you head to the right, you're going to fall off the cliff and die. If you head to the left, you're going to hit the escape path. Therefore, you can make that decision. Okay. Now, these sorts of decisions you make all the time. Okay, and you use logic to make those decisions, perhaps without even realizing it. Okay. The example that I usually use is looking at the weather and deciding what to wear. Okay, now sometimes the weather tricks you. Like today, it's super sunny outside, but it's pretty cold. However, I know there's no clouds anywhere in the sky, right? So I know that it's not going to rain, so I don't need to wear waterproof clothes. Okay, so that's one way that you can make logical inferences. Now, because of the way the world works, sometimes even though you make these decisions and you might be entirely logical, they don't always pan out right. That's because you're operating without knowing all of the different bits of information that you do, right? The way that AI works in video games, they have what's called a decision tree, right? They will use information. I mean, as an example, it might be something as simple as if the player is in the enemy's line of sight, the enemy's going to fire. If the player is not in the enemy's line of sight, the enemy is not going to fire. Okay, you might brag about how advanced your AI is, like in Half-Life, the original Half-Life, where if the player was in the line of sight, then the enemy would shoot. If the player was not in the line of sight but was within range, they would throw a grenade. Okay, so, that's obviously in real life, there's a hell of a lot more information that we need to act on, but we still use those logical inferences. Now, you will be pleased to know that we don't have to deal with the messy real world here. We only have to deal with the logical world of Mr. George Boole. And so, I have created, for your delectation, a series of puzzles, riddles, if you will, okay, worksheets, which are available on the Google Classroom. Hopefully you will have found them. They start off fairly simple. The ones toward the end, you're probably going to have to write some stuff down in order to eliminate some of the different questions that are on there. Some of the different possibilities, I should say, from the questions that are on there. There are no trick questions. Okay, you are given all of the information that you need in order to solve the problems. Okay, now every step of the way, what I'd like you to do is I would like you to not only answer the questions but also explain your reasoning behind them. Okay, so if I just open my worksheet here, I can see the first one on there. I mean, get your worksheets open, maybe, and let me just see if I can add this to the what's it called? There we go. There's my logic worksheet there. Let's stretch that out. Maybe have a look at that. Have a look at that first one. So here, Kevin, Joseph, and Nicholas are three brothers. If the following statements are all true, which of them is the youngest? Okay, so all of these statements are true. Kevin is the oldest. Nicholas is not the oldest. Joseph is not the youngest. Okay, now you've got to be careful here because just because Nicholas is not the oldest, it doesn't mean he is automatically the youngest, right? Because there's three of them. Okay, he's either oldest or he is youngest. Yeah, Alt F4 isn't going to work in Linux, is it, Alex? Yeah. So let's have a look at this. Kevin, Joseph, Nicholas are three brothers. We want to find out who is the youngest. Kevin is the oldest. It straight up tells us Kevin is not the one. Okay? Nicholas is not the oldest. So Nicholas could be the youngest. Okay? So it's out of Nicholas and Joseph. And then the third thing says Joseph is not the youngest. Therefore, Nicholas must be the youngest. Does that make sense? Sudo shutdown F. How old is your Linux kernel? You want something like sudo system control power off, you know? And I'm certainly not going to run that from the command line, am I? Okay, so section A should be fairly straightforward. Section B, a little bit more challenging. I've tried to add a couple of jokes in there to make you smile. Have a go at that. Section C, the first question in section C is actually from an A-level exam paper. So see how well you did. Obviously, I've adjusted it slightly. We got Mr. Jones, Mr. Flibble, Mr. Flimflam, Mr. Brontosaurus. They're obviously not their real names. The last one on here, you're probably going to have to write out or draw out something to help you visualize what's going on there. Okay? Yes, Amy. Yes, that question. Okay? So, have a go at that. If we just go back to here, you'll see I've even added some logic in here. Try to answer all the riddles. All the rules of logic apply. There are no trick questions. If there is an angry cat on this slide, you must do the questions in order. Is there an angry cat on that slide? Oh, ladies and gentlemen, Alex McBride with all of the top tricks from the late 90s. Right, there's nothing really more that I need to tell you on this on this video. Okay, so what I'm going to do in a moment, I am going to end the stream, and I'm going to hop onto the Discord chat. Okay, which means if you've got any questions about the logic problems, you can ask me directly there, and I'll be able to help you out. Okay. The final thing that I'm going to do, and I'll stick this up on the classroom here. I don't want you to write in the chat. I'll stick something up on the Google Classroom so that you can respond to this. Write a sentence, explain how logic can be used to help us make decisions. Come up with a set of logical rules which will allow me to infer something about your own life. For example, if I'm late for school, I did not sleep well. I do not sleep well if I've been up all night playing Sonotic. I am late for school. Okay, there we go. So, anyone got any questions about what they need to be getting on with? No questions from Ollie. Anyone else got any questions? Nope. Cool. Don't know if this is going to work. Probably not. I will try and get some video for this. How about that? We need a fade out video. You know, one of you guys can make one of those. Bruno or Elenia, you can make a fade out video so I can finish on this. Yeah. Oh yeah, no, Bruno, you did give me a fade out video. Yeah, find it for me again, and I'll stick it on there. Okay. Right. So if there's no other questions, I will hop onto the Discord chat, and then you guys can tune in with any questions that you might have. All right. Thanks very much, everybody. Wait, let's just wait for this drop. Here it comes. Hope you guys are ready for this. What a tune! Right, that's it. I'm out of here. Bye!